All right, I'm really excited. Thank you all for joining. I'm really excited to have expert Panayotis from Greece, who's going to speak to us about an incredible design sprint experience that he had, that he was sharing to me, that I said we have to share this more broadly. So I asked him to come and speak to the rest of the group, and we've also opened it up to Google developer groups and the general public, so feel free to share this as well afterwards. So a little bit about Panayotis is he has a background in finance and statistics and is now working at X-Labs on moonshot thinking and moonshot ideas, and he's a technical lead over there. Part of the amazing work that he's done, and I'll let him explain some of that, but part of the exciting piece of all of this is the way that design sprints have allowed him and allowed his team to cross over many different barriers and enter into the chasm of the unknown. So without further ado, Panayotis, I'll let you go ahead and take over, and thank you very much for sharing your experience.
So thank you for the opportunity to share it, and I hope that my experience can lead you to do some crazy stuff like we are doing here. And as I was saying to you, Melissa, earlier on, the thing, it was so quick but so good. And like we were supporting as GDG here in our town, we were supporting the NASA Space Up Challenge. And I met two judges over there, and I was saying to them, yes, this is fun, but let's do something more concrete. What can we do for helping NASA? Has NASA got any challenge, or or NASA is like the god of everybody? And he said to me, listen, the major problem that NASA has is that astronauts are losing tools and objects inside the ISS, the International Space Station. And these costs them a lot on training the astronauts not to lose them, and costs them a lot in replacing objects and tools. And first thought that I had, it was like, I don't know, let's use beacons, let's use, I don't know, create an IoT. Didn't know if there was no Wi-Fi on ISS, but apparently, unfortunately, there isn't a Wi-Fi. And well, we gathered together, like 2-3 people at the beginning, and in a really quick time of 2 weeks, we hosted a design sprint on this challenge, and we had the chance to talk to an expert from NASA, from the base control, and she opened up and explained to us that indeed, for an astronaut, for NASA mainly, losing an object is really a pain in the neck, in a way that astronauts, and I learned that throughout the design sprint. Like, I didn't know anything about microgravity, about astronauts' life, about the environment, or the ecosystem that they have in the ISS. And she explained a little bit to me about the major problems that astronauts tend to, their muscles, they're not really on shape when they are on microgravity. And the more they're using it outside from their gym period, they go to gym, and they need to be fit outside their gym period. The more they use them, the less they are productive on their mission. And she as well explained. She shared with me a couple of pictures and a few more insight of this challenge. And well, in 2 weeks, as I told you, we hosted the design sprint, and we shared the challenge. I share from my technical point of view how it could be solved. And we had like 65 people. 20 of them were developers, and all the others were from mechanical engineers to space engineers to really different background. We had also we were lucky that we had in the audience, and then he's one of our team, a biomimicry UX UI designer, which I think that he was the one that really opened up my mind, and as we said in the description of the hangout today, really made me thinking outside of my comfortable zone. Like I was really pumped up about, I really like algorithms. So I was like, okay, it's easy, this is easy, and the other one is easy. We are a developer, we can fix anything. And suddenly I started thinking that, well, it's not that easy. And we got so many constraints in front of us that we can overpass, yes, but still are there. And sometimes only with technology you cannot really solve all these big issues if you don't adopt or adapt technology to different situations and needs and requirements. And so from the initial idea of having beacons or sensors or all the super cool latest technologies, we went 2 or 3 steps back, and we said, why don't like the object are missing because of which factor? And it came out that the factor was a human error. So we thought, okay, why don't we prevent losing the object instead of losing time in finding them? And by preventing them, we can also attach a little bit of machine learning technology and give the data of the prevention to the machine learning, so that it can predict if an object is going to be lost or is just been left there by the astronaut. And so we split the design sprint in 2 main stages. The first stage is like creating an app, a simple Android app using proximity, nearby APIs, fencing, geofencing, and creating like a safety zone before losing the object. 2 levels. Like the first level is going to be in X meters, and is going to like notify the astronauts that, hey, pal, you're losing the object, or it's on purpose that you left it over there. And the second notification is like a dangerous zone, like the object overpassed the first level and the second level, and it might be get lost. Parallel, we are still talking with the expert, and the expert really from NASA said that once an object is lost, it's lost. It's like a black hole inside the ship, and it's completely lost. It cannot be found. And there are a couple of pictures that if you see the ISS inside, it's full of cables, it's full of monitors, laptop, everything is like floating around, and it's really hard. Can imagine like find a little tiny screwdriver, like I don't know, 3-inch screwdriver in between cables that in between cables, other object on and off floating in front of you. And so that was that's the first stage of our implementation of the challenge of finding a solution. And well, the second stage is once we prototyped that application can work in order to decrease the object lost, then all the data can be communicated to a machine learning in order to be able to either predict and or either autonomously, instead of having the notification, autonomously instruct something that at the beginning we were thinking about a common drone. And then this guy from the biomimicry, we had a couple of nice discussion talking about how to replicate nature with technology. And I think that's an interesting field to follow, because yeah, everything is already here, is already turning around your head. You see things happening like miracles. So there's no point to reinvent the wheel. There's everything. It's handy. We just need to replicate them using technology. And yeah, he came out with this jellyfish drone because the main constraint in our challenge is the microgravity. So we are talking about an environment which the atmosphere is completely different from Earth, and really don't know, at least my background doesn't allow me to understand or to know how an object can float. And it's nice because now we are thinking about prototyping in swimming pools, inside the swimming pools, like throwing an object and videoing them and giving the feed to the machine learning, so you can at least try to understand how the machine can calculate it and on a microgravity atmosphere. And yeah, more or less that's the challenge that we are facing. And it was the really interesting thing is that it was really quick. Nobody knew each other. We were like I don't know, like 20 minutes we were speaking to each other, and after that okay, let's do it and let's fix it. And it's not really hard to think about it.
And it's really pretty amazing that you were jumping into biomimicry and you were learning about microgravity and thinking through using technology in ways that had never been done before. And you had told me before we started broadcasting that previously, what were the astronauts using to avoid losing their tools?
Yeah, they're still using that because our applications haven't been validated yet. But they're using like Velcro, the strap thing that they are putting on each object. They're putting a Velcro side, like female, male, and then they just attach them on their suit. So it's really primitive, if you want to think that way. And yeah, to think about NASA, and they went to the moon, and they're losing object inside the ISS, and they're trying to attach them with Velcro on their suit or everywhere on the ISS. And yeah, talking as well to the NASA people, we were talking about using as well like VPS from Tango platform, and using quite new technologies, but still I'm not saying easy technologies, but not like we are inventing technology, new technologies. Like we are trying to use technology that are already here. And yeah, they were saying to me that yeah, they saw that in movies, and they didn't know that actually there's a platform that can do VPS or can do motion learning, or yeah, can visualize positioning without using GPS.
So you had actually created a video that was kind of a fun video that outlines the challenge, and I also saw the deck that you have, which shows some of the spaces. Could we see some of the spaces on the ISS and some of the physical challenges and the team that we were working with?
Yep. Second.
Yeah, one thing that was really amazing is astronauts and scientists that are working at NASA are experts in their field. And Panayotis himself is an expert in statistics and machine learning. And then bringing in an Android developer and bringing in, you said that there were 65 different people who were working on this sprint.
Yeah.
And having all of those people, I have a bunch of questions about how the structure of the sprint went, and how you were able to leverage everybody's strengths, and also to jump into such an unknown territory when you're dealing with microgravity. All of these, I think, are really exciting topics.
Well, we had the 4 main team members that hosted the design sprint, that they were from they were skilled in their background, so about the microgravity, they were really easy to go, and they were really explaining in concrete words, but easy to understand words, what was all the microgravity ecosystem, the atmosphere, and I was trying to be as simple as possible about the platforms we were going to use. And the nice thing is that people in the audience were really like amazed and amused about knowing all those different fields could link together. And yeah, well, like what the microgravity has to do with tango, for example. And yeah, we can link it by using the platform in order to, yeah, the common vision is to trace the object. And it's like the BBC now there. And yeah, the audience were really they were participating a lot into the discussion. And the amazing thing is that after we did the introductions, and we did the MPV, and we tried to do all the voting and on the different ideas, they were really tense, and they were really into trying to help. And they were like, no, why me and not him? Why me and not her? Everybody was really active and proactive inside the design sprint, which is I think that the best result is not to be disappointed in a design sprint, because sometimes you get the feeling that well, my idea is super wow, why they didn't take it? And you have this little other side of the middle. And but I guess that how you manage to conduct or to run the design sprint has a lot to do with how people can get enthusiastic about a different idea. It's like, from my point of view, I was rejected in bracket my initial idea, and I find it really interesting to see that indeed it was good that we went on the other way, and it was with really going out to your thinking box. It's like we are not alone, and we need to share our things with other people, and they need to share their skills with us. And by combining those different backgrounds, we really came out with I guess an interesting idea that is going to be perhaps something different and something new. And as I was saying to Melissa earlier, that the thing is that I'm trying to say to my team that it doesn't matter if the results will be okay, a go or a no-go. The thing is that we did it, we tried. So the major thing is that we didn't think about constraints. We thought straight away about solution of the challenges. Constraint can be fixed on the way going there. To kind
of take a step back, because I think you and I are familiar with the challenge and with all the technologies that you've been exploring. But I think, could you take us through the deck that you have and show us a little bit in terms of the structure of the team and the approach that you guys decided to take, and sort of the next steps where you're at as a team?
Okay, let me not mess it up everything now with a screen share. Okay. So shall we start from the video?
Yeah, that'd be awesome.
Okay. So, well, I guess that was the challenge. So the challenge is that NASA has identified autonomous logistic management, like ALM, like the losing object in space, and that's the main, as we said earlier, that's the main big problem, challenge, let's say, that NASA is facing at the moment. They tried different ways to tackle this challenge, but without any good result, and they're still on a research phase. It's like NASA, if I remember correctly, every now and then, I guess every 3-4 years, is sending out some documents on the level of achievement they did for each and different department they are challenging with. I don't know, like for the mechanical parts, they have some dedicated documents when it's findable also on the internet, so it's not something that is top secret for anybody. And they say that, I don't know, during the last 3 years, for example, we reach from level 1, we reach level 3. Like level 1 is research, like they're doing research but not development. Level 3 research is actually prototyped and they're trying to develop it. And I think, but I'm not sure about that. It's level 7. It's they're using that technology or that that service that they were working on. And on the ALM here, the autonomous logistic management, they are still on level 1 to 2. So it means that they are researching ways, they're searching and looking for ways to be able to cope and tackle this challenge. And well, I don't know, yeah, that was a little bit the agenda of the challenge. So if you can see that it was a really rapid challenge. Like nobody had time to drink a coffee or to drink water. We were like closed in from 2 to 18 p.m. That was the team. So you see Billy, the biomimicry guy, Yorgos, the space advisor and prototype advisor. And the nice thing is that we had 4 females inside it. We have 4 females inside the team, and the team is really growing up because there's now one developer, Android developer from Portugal that joined us. And it's really nice that it's not only different background, but it's also different cultures. And really, the more you are in a team, the from my point of view, the better it is, because it makes things and processes quicker. Well, as we were talking before, those in the red circle are the Velcro they're using for attaching all the object. Now, if you see over here, of the ISS inside, and yeah, we're thinking, and that's what we're trying to do and to achieve. That's good. And yeah, so this is what we came out with, like beacons, but we need to still get clear from NASA regarding interferences with ISS. They say to us that the beacon frequency, it's more or less like the Wi-Fi frequency. So on the ISS, there is Wi-Fi. So the 0.02 is like Wi-Fi. There is Wi-Fi on board. So it make also our idea much easier to subsist. And yep, we are going to create an app, as we said, about preventing object to get lost or to be missed. And this app is going to be on Android, and different other technologies we're going to use is like machine learning, AI, visual, VPS, Tango SDK. There's a little constraint on the Tango SDK, which is not really of a concern of us, but we need to switch off the accelerometer in the Tango, because if I tried it for
and the accelerometer is what can detect what direction it's facing, correct?
Yeah, but in space you have, I guess the accelerometer is like with the magnetic field, and in space you have when you get a G-force, like I try to put, I don't know if everybody have played a little bit with a Tango. You just put a cat, like AR, you put a cat, and then you take a video or a pic. You take a picture or a video of the cat. And I tried it on a train, and I saw that when the train was turning fast, the cat was completely away. So there's no tracking on a G-force, or where you move too fast your Tango device.
That is a really interesting challenge, because the accelerometer, for those that haven't played around with it, is just tracking XYZ coordinates as you're moving through space. And so if it's only sensitive up to normal speeds, I would assume, unless you're starting to get into materials that can sustain G-forces, which I would guess are extremely expensive, and not sort of off-the-shelf SDKs. So trying to envision or prototype something that could sustain microgravities that can. So all of this kind of leads me to a question of, you mentioned that you allowed yourselves to let go of constraints for a certain period. How did you navigate some of these unknowns or perceived impossibles to allow yourself to envision the dream state, the goal state?
Well, thanking to the help of the others as well. Yeah, it's how to explain it. It's not really easy to explain. Like we said before, it's within the input of different people, you can actually let go your fears, and yeah, you can be invincible in bracket. Though on the way there, like the accelerometer, you get those constraints, but again, with the input of everybody, it's much easier to overpass them. Of course.
Was there anyone in your group who was a particular expert on a subject who would be sort of the naysayer, someone who kept bringing you back to reality, saying, that's not going to work, that's not going to work?
The most one was like George, the space advisor. Despite his skilled on space environment, he was really on Earth. So it's like, hey, come back a little bit, because we need to see if it's working or not. And
what were some of the ways that you were able to balance that sort of perspective?
Not to leave aside my objective, but to understand the actual need and requirements now, without really rejecting what I'm thinking, and then parallel try to fix what I'm thinking in order to be able to demonstrate that it's working with the new input and the new knowledge or the new thoughts of the team.
Very cool.
Well, yeah, the machine learning AI is what we said earlier, like training the machine to try to. This is another nice and dreaming challenge. It's like teaching the machine learning to predict the trajectory of an object lost inside the ISS. So it's that's another interesting, really challenge that we are going to be facing on the second stage of our design sprint. So this is a little bit what we are trying to implement. So you see the branch is goes outside safe zone. It communicates with a beacon or with a receiver, and that was the initial with a drone. That now we're gonna use the jellyfish in bracket, and so the branch is outside the safe zone. Sends to the beacon the position. The beacon talks to, I don't know, either Wi-Fi or beacon, and then it goes to the database. It recognizes that the branch is somehow not approachable by the astronaut, and it sends the notification. Now over here, there's one more step, as we said earlier, that we have two levels of safe zone. One safe zone is notify the astronauts that she might lose the object. And if the astronaut says, no, I did it on purpose, I left it over there, so the notification goes off. Otherwise, you got a second notification when the tool actually overpass the safe zone limit. And this is in little words what we the phase A and phase B, like we were saying earlier as well, like preventing and later on autonomously locate assets lost on space, and use a mini drone. At the beginning, we were thinking about a mini drone, but as I said, that with the biomimicry guy, he said that propellers is not really sure that they could work on a microgravity system, because it's like it's like being on a swimming pool. And so he came out with the idea of using a jellyfish-shaped drone. I guess that if you go to YouTube, you can find a couple of experiments that they are trying to manufacture some medusoid, some jellyfish or calamari drones, which are as they're floating, they are the best. It's the best case scenario in a microgravity environment. Yeah, and the next step, and we are actually on step C. We are arranging a second sprint session with the core team, and we got some feedback regarding technologies, and we almost covered all our anxieties. Like we are on the good path, I guess. And once we arrange the second sprint, we are really open to share, as we were saying to Melissa as well, like anybody, we would like to share our achievements. And if there's any person interested in helping us out or giving us a hint, you're all welcome to join us. And as a point is like, finishing the life cycle of the sprint, and put down the ultimate deadline for phase A and phase B to be accomplished. And I guess that was it. Ooh, sorry.
So in terms of, you're right now working at X-Labs, and you're thinking through product design of some pretty moonshot ideas. How would you say that this sprint compares to what you do on a day-to-day basis?
It's a day-to-day basis. No, I'm joking. No, we are trying to have this approach at our facilities in bracket. Like, we are thinking big. So it's not, we are trying to, we got inspired by the Sulfur X. And so we were one of the first cities that did the beta organizer, something like we really tried out one of the first design sprint. that came out like 3 years ago, I guess, 3.5 years ago. And we really like the idea of starting from the solution in order to be able to solve the challenge, and not starting from the problem. So everybody is thinking about problems, and they're not really thinking about solution to be able to fix the challenge. And I think that well, because we have a team of 15 people on and off, and they are all from really different backgrounds. Like we have philanthropists inside, and we are talking a lot. Sometimes we're talking. We are not working really. Sometimes we are just sitting down, drinking coffee, and talking about philosophy. But I think that this is really food for your brain, and it gives you a completely different approach to the day-to-day operation you have in your life.
When you say that you prefer to start from the solution rather than starting from the challenge, what does that mean to you? And what does starting from the solution enable you to do? I'll ask one question at a time.
Yeah, okay. Starting from solutions, I think that well, it's a bit philosophical, but I think that we are living.
I'll say that I asked that because I encourage the opposite, but I do think that perhaps maybe my interpretation of what you mean by starting from the solution is opening your mind up to the potential of where you could be, sort of the dream state. Is that what you mean? Or I don't want to put words into your mouth, but
no, yeah, I mean that I think that there's always a solution. It can be no solution. Always there's a solution in life. And we are lucky that we know technology, and we know some, we are software engineers, or we know some algorithms, we know artificial intelligence, machine learning, and we can find solutions to problems. So instead of just focusing a lot on the problem, let's focus on fixing it. That's what I'm what my approach is.
Does anybody else want to chime in with any questions about either his approach or handling the tight deadline? I think it's really interesting that you were able to run an effective sprint in such a short period of time and generate a lot of ideas with a very large and very diverse group. So I have questions on that side, but does anybody else who's inside the Hangout have any questions?
Yes, actually, I have at least a comment. I think it's very interesting, and I do agree that obviously there's always a solution to a problem, and I would go even further. I think sometimes we get to the solutions very, very fast, and getting to the solutions very, very fast gives you a nice opportunity to go back to the problem. I mean, if you don't focus too much on getting solutions, but once that you have solutions, and getting back to the problem is a really nice aspect. That's why I liked a lot the comment when you said, yeah, a sort of solution is also just getting the problem out of the way. And I think you can come up with this idea once that you have solutions, and you say, well, you know, what was the problem originally? Maybe we just get rid of the problem. I really like the approach. At least I like to interpret it that way.
Yeah, at the end of the story, we create problems. There's no problems in our lives. We created them. You know,
yeah, I like the idea of coming up with the solution and then getting the problem out of your way, which is what it sounds like you did over and over again. You had constraints. You had a lot of constraints. There's a reason that NASA is using Velcro, is because there's a lot of There's a lot of interference that happens. There's a lot of devices and technology that's currently not as suited or doesn't function at all in microgravity. And rather than focusing on those and letting those hold you back, you simply push them out of the way and focus on coming up with the right thing.
Yeah, and on the other side, because it's not my day-to-day operations, like working for NASA, I'm not working for NASA. So I'm not, I think that everybody has got a role in this world, in bracket. So, I mean, NASA is focused on making rockets more safer. So they don't have the luxury to think about some different approach. While I'm a newbie in bracket in this field, and I've got all the enthusiasm to bring my ideas. Perhaps they are working, they're not working, but at least it's like we are exchanging and sharing thoughts that could give a solution or could ignite a chain of reaction that leads to a solution. And yeah, I think that if you're for example, if you're a lawyer, you might not thinking about technology and how can technology help you, because you need to solve your client's problem or solve your client's law problem. While me, that I'm not a lawyer, and I can help you to see it from a different point of view.
And I think that was one of the things that we were both so excited about at the beginning, which is venturing into the unknown. So what do you think it was about your personal experience, either working at X-Labs or simply, how did you have no fear going into solving a problem with NASA? What empowered you to make that step into the unknown?
Across my craziness, I don't know. I'm pretty crazy, guys. I don't know. I like to challenge myself every day, and I think that, yeah, the main thing is pushing yourself to the limit. Like as I said before, for me, there's no solutions. Yeah, there's always a solution. There's no solution for me, and as much as I push myself to the limit, and of course it's not that everything is so idyllic and it's so pink and everything is like on a green grass near the mountains. So you fail sometimes, but the thing is that by failing, you see that perhaps you had a different approach. You could have a different approach for not failing. So that's the thing that I think also the design sprint helped me a lot with the NASA. It's like, well, my first idea failed, but here I am and sharing with you the different idea that came out after the first idea that failed. And
what was that first idea? Just to sort of give some context, because you mentioned that it was an initial idea that you'd come up with, that you'd brought it up with the team, it came up in ideation, and it eventually didn't get voted, or perhaps it was discussed and actually decided against. But what was that idea?
No, the idea was to put sensors like Tango sensor everywhere in the ship, in the international spaceship, and for having a more accurate localization of the object. But that was from my little point of view and my enthusiasm about the Tango technology and platform. And it came out that it was really, well, it wasn't so convenient to put Tango sensor on all the spaceship, because also if you saw the picture, the cables, and there were a lot of interferences in the sensor and a lot of movements going on and around. And so we, instead of using the sensor or thousands of sensors, we went to beacons and using beacons. And then it came out that they have a Wi-Fi on board. So we thought about building an IoT over there, and I don't know, aligning different technologies all together in order to have a more accurate positioning of the object. And yeah, but still, my failing perhaps I don't know, but my failing could have led the whole team to see it from a different point of view, and not focusing only on the problem.
And you ended up going with a machine learning localization process that you're going to be able to test in water?
Yeah, and that's another nice challenge, because we are trying to train the machine to understand the floating of an object, and that's the best way, and the best similar way is to throw an object in a swimming pool, in the sea. I don't know, in the swimming pool, and to record it and to give it to the machine in order to be able to predict and to analyze all the data that we're giving to the machine. And well, as I said, we're gonna do some funny video about the backstage of all the experiments we're gonna do, and I'm gonna share it with everybody if you want to. I don't have problems. And yeah, so the major problem is to be able to make the machine understand how an object in microgravity could behave, because it's completely different. It's a completely different behavior from the normal Earth atmosphere.
So this actually reminds me of, I took a course with Tom Chi, who was the former UX director at Google X, and he now teaches a course called Prototype Thinking. And many thought leaders, a lot of folks at IDEO, Tom Chi, many other people believe that you shouldn't come to a meeting without a prototype. And it sounds like from here on out, you're going to just be creating multiple experiments and prototypes and just start playing with things. Because we can sit around and ideate and put things on yellow Post-its for hours and hours. But once you actually start to see how the various devices are interacting in microgravity and figuring out ways that you can simulate the microgravity is really how you're going to make your decisions moving forward, yeah?
Yeah, either me or the machine. I don't know. I hope the machine is going to make the decision. It's much easier.
The magic black box of deep learning.
Yeah. No, but
so do you have any advice for folks who are thinking about tackling a project that they feel is outside of their realm of expertise?
Test yourself. Try it. Don't... well, just go for it. Dive into that. Well, I guess that the less you're thinking about it's outside your comfort zone, the more you are working on it. So I don't think well, I got a bit scared when you said to me, let's talk about outside your comfort zone, and I realized that moment when we said that oh yes, I was thinking outside my comfort zone at the design sprint. While at the design sprint, I didn't have the time of thinking that I might think not comfortable. So just, yeah, don't give time to your thoughts to grow into I shouldn't do that, I shouldn't do that, this is not my field, this is not my experience. Go for it.
How did folks, so for example, when when some of the astronauts were talking to you, they brought expertise that you didn't know, and you brought and the biomimicry UX designer. All of these folks brought in various forms of expertise. Did you have a structured way of presenting the information that everybody had, or was it just through questioning and curiosity? How did you learn from one another?
Well, I think that was everybody's curiosity about how we can link everything together. We had like 5-7 minutes intro on each field of our competence. Like I was talking about machine learning and how can machine learning predict things, and the biomimicry guy was talking about the microgravity from the design point of view, not the atmosphere point of view, and saying that drone perhaps is not the best yeah, it's the drone
Form factor.
Yeah, perhaps we might think about some, yeah, as I said before, jellyfish shape drone, and then the space advisor came in and talked to us about the astronaut environment and ecosystem on the ISS, about the microgravity, and the Android developer getting too excited, saying that okay, well, we don't do that, and that. It was like everybody's got like 5 to 7 minutes talking about is her competencies, and then it was more like a big round table of brainstorming. Like we knew that the challenge was that one. We started with the big failure of the censoring all the ISS, and yeah, we came out with some really interesting solutions that could fix the problem that exists.
And as a final question that I have, you mentioned that you've got next steps and you're going to be working on experiments and prototypes. You're based out of Greece. Do you know of any of the experiments and some of the needs that they're facing, or the Android app, some of the design challenges that they might be facing, that you could put out a call to action?
Android apps design face the problems that they're facing.
Well, basically, how can the community get involved if they're interested in taking part in one of the experiments?
They can join the. Well, that's a nice question. Well, we never thought about that. It's a word to mouth. It's a mouth to mouth word passing by. Well, there's a link I can share with you, and if they want to join us, and mainly through the GDG Thessaloniki here, they can learn more things about what's happening, because we are supporting, and they are supporting us a lot. And well, I am part of the GDG Thessaloniki over here, and yeah, I guess through our communities. And
very cool. Does anybody else have any questions?
I'd like to, am I coming through? Yes. This is Tom. Yeah, no, I'm been mulling over this problem solution first thing, and I'm wondering, did the team produce any low-tech solutions? I was remarking on the fact that Velcro was evidently a solution that somebody came up with earlier, very low-tech, and it seems to have reduced the loss rate down to, what was it, 3% or something?
Yeah.
Were there any, what was the lowest tech kind of solution that anybody proposed in the team?
I think, thanks for the question. It was, I think, our first stage that it's a common, in bracket, Android app for pushing notification to the astronaut. So this is, I guess, from the whole challenge, it's the, not low, but it's the more reachable solution for the time being.
Okay, so the challenge, the problem was already, there was a solution baked in, kind of. It needed, the first approach would be through an Android app, as opposed to, for example, I don't know, something attaching, I don't know what number of instruments they use at any one time, but let's say around 6, if they could attach them to their outfit, that might
they're already doing that. But sometimes they got some Velcro as well on the suit.
Okay.
So, but sometimes when you're floating inside the ISS, you get caught by a cable, and then the tool detach from the Velcro of your suit. So, and there's a lot of noise as well. So yeah, I didn't say that. There's a lot of noise inside the ISS. So you're not really listening, in brackets, if or feeling if the tool is detaching from your suit.
Right.
So yeah, that's
okay. So they're pretty convinced that some tools are going to get away, and we need something technological to find them, rather than just a chained. Okay, cool. So, but yeah.
So at least this is our background. So that we are thinking about a technological approach, perhaps somebody else can think about another approach. And I don't know. It's like what we thought at the beginning, and seems that it's working in bracket. Theoretically, everything is working.
I mean, and I think you can start in a design sprint at any level of already closure on the solution, limiting or constraining the solution. But yeah, I mean, it does sound like what you described, that you did understand the problem space pretty well in terms of understanding that loud noises could distract them. Sounds like you got a really good description of what some of the problems were.
Yeah, I learned it in the design sprint because I really didn't know anything. Yeah, because I really didn't know anything about the ISS, and yeah, I got tripped away, and it's like it's a nice dimension, and yeah, it's an uncharted territory, as we said. Well, everybody, when he's a child, he wants to be an astronaut or a pilot, so I got the chance now to help them.
Yeah, it's a domain that does bring back childhood thoughts of wonder and so forth. Yeah, very cool.
The first rocket that burned your roof, you know.
Absolutely. Thanks. This is a very cool case study.
Thanks. Well, I hope that you like that.
Yeah, I just want to thank you again for sharing your progress so far, and I'm really excited to see how the second sprint goes, and definitely share some of the photos and videos of your upcoming experiments. I think that's going to be really fun. And let us know how you guys do with working in microgravity. I think that could be the future, perhaps, if we are working in Mars.
Yeah.
Awesome. Well, yeah, thanks again. And with that, I will sign off.
Okay. Thank you very much.